latitude by meridian altitude of the Sun, or meridian passage, or what is commonly known as the noon sights, is probably the oldest celestial observation that is used to determine latitude. Meridian passage, upper transit, meridian altitude, and local apparent noon are the terms used for noon sights. They all mean essentially the same thing. Diagram, on the plane of the celestial meridian, and illustrate the position of the Sun at local apparent noon. Altitude. Celestial pole north, and celestial pole south. Perpendicular to the celestial meridian is the equinoctial. Declination is the body's angular distance from the celestial equator, and the location of a body along its hour circle, and is measured north or south of the celestial equator in degrees from 0 to 90, similar to latitude on the Earth. Diurnal circle is the apparent circle, or parallel of declination, described by a celestial body, in consequence of the Earth's rotation. Our circle is a great circle on a celestial sphere, passing through the celestial poles, and containing a point on a celestial sphere as a star, or the vernal equinox. Vertical circle is a great circle on a celestial sphere, whose plane is perpendicular to that of the horizon, and whose diameter runs from zenith to nadir. The shaded triangle is the astronomical triangle. All celestial bodies travel along their respective diurnal circles. As the bodies move along their diurnal circles, all other circles follow the celestial body. The distance above the horizon of the elevated pole is equal to the latitude, measured from the equinoctial to the zenith. Zenith distance. Declination. Case 1, when latitude is greater than the declination, and of the same name, both north or south, add zenith distance to declination, and give resulting latitude the common name. The distance above the horizon of the elevated pole is equal to the latitude, measured from the equinoctial to the zenith. Declination. Zenith distance. Case 2, when declination is greater than latitude, but of the same name both north or south, subtract zenith distance from declination, name the resulting latitude the same of declination. The distance above the horizon of the elevated pole is equal to the latitude, measured from the equinoctial to the zenith. Zenith distance. Declination. Case 3, when latitude and declination are of opposite name, subtract declination from zenith distance, and name resulting latitude the same as the name of the zenith distance is name opposite to azimuth. The PZX triangle, or the navigational triangle, is a spherical triangle used in astronavigation to determine the observer's position on the globe. It is composed of a 3 reference point on the celestial sphere, where P is the celestial pole. It is either north or south, Z is the observer's zenith, and X is the celestial body, such as the Sun, Moon, star, and a planet, subtended by the angles P, Z, and X. Co-latitude is the complementary angle of the latitude in spherical coordinate system. It is the difference between 90 degrees and the latitude. Zenith distance is the angular distance from the zenith to a body, It is found by subtracting its corrected altitude from 90 degrees. Polar distance is the angular distance from the pole to a celestial body. It is found by subtracting the declination from 90 degrees, if the latitude and declination are of the same name. But if it is in contrary name, add the declination to 90 degrees. Thank you for watching. Please subscribe, and click the notification bell, for you will be updated for our next upcoming video.